All right, let's keep going. If you want to, you could fill out the whole table now. It's not how I have it written out in the PDF, but if you just make the D's the sums of the C's, the E's the sums of the D's, etc., you can fill out the whole table and do it very much just based on the numbers if you want. But the PDF walks us through kind of one column at a time and asks some more general questions as well. So let's go ahead and go with that. So we've got the C's, we've got the numbers. Oh, I don't know what that's doing there. We've got the numbers for the C's, and we don't have a closed formula yet, but we're going to go ahead and use something that's a very standard fact about summing an arithmetic sequence. And I have some other videos about that, and I might even make some more videos about summing an arithmetic sequence, because there are lots of cool things you can say about how you discover the formula. But there is a fairly simple formula for that, and that is that sum of an arithmetic sequence. I'll say the version that I usually like to emphasize. That's equal to the number of terms times the average of the first and the last term. The way I like to say it is that this average usually is an absolutely completely wrong way to average a whole bunch of numbers, just average the first and the last. But in fact, it gives you the right average for any arithmetic sequence. And if you know the average of a whole bunch of numbers, and you know how many numbers there are, then you just multiply by how many numbers there are to get the total. So that may be an unfamiliar way of expressing that, but let's see. This guy's called B, so I'll call B. It's quite likely that you've seen a formula like that for the sum of an arithmetic sequence. Okay, so that's how I like to think about it. Okay, well in this case, what is that? It's n. Ooh, and here's the thing. Ooh, forgetting my own convention here. It's a little tricky because often we get into standardized conventions and formulas. We're going from the 0th term to the n minus first term. And I know that might seem a little weird, but trust me, it's really the right thing to do in this case. Okay, and that's just 0 plus, and we know that b sub n minus 1 is just n minus 1 over 2, so we don't need that 0 plus. And so we're just going to get n times n minus 1 over 2. Okay, so that might look, if you have memorized the formula for the sum of the first n integers, that is an n times n plus 1 over 2. This is a minus because remember we stopped short and we didn't use n, we didn't include n in there, we just went up through n minus 1. So this is just the sum of 1 through n minus 1. So that's just, to be really explicit, 1 plus 2 plus 3 plus dot 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 plus n minus 1. Everything but not, up to but not including n, gives you this formula. Okay, so there's a closed formula for the C sub n's, and we had a really simple closed formula for the B sub n's. These were just n. It was right. Oh, it's not wanting to find that for me. There it is. B sub n is n, and of course A sub n is just 1. And here's the formula for C sub n. So eventually we were going to want to actually try to guess the general formula for anything in this whole table, but we're not quite there yet, probably. Okay, so now let's go ahead and let the D sequence be the running totals of the C's. Okay, and we're going to try to be smart about that. You might have already, working this out, realized the efficient way to do this. So it's going to start with 0. Okay, well, 0 plus, so that's just because the default 0. Then just 0 summed up with itself just as 0. 0 plus 0 is still 0. Kind of boring. Okay, finally, we get a 1. Okay, so that's a pattern. It always starts with some zeros and then a 1. That's interesting. Okay, now finally 1 plus 3 is 4. Okay, now how would we get this number here? Do I have to add 1 plus 3 plus 6? Well, think about that for a second. Might want to pause the video. Is there a slightly more efficient way to do it? Yeah, we just need to add the 6 in here. We got the running total. Like if these are my incomes, I got paid $1 and then $3 and then $6. Okay, the $6 is going to add to the $4 in my bank account and become 10. And that happens to be the same number as this. That's interesting. Okay. And then the 10 in my already my bank account plus 1 new day's worth of money is 20. And then 20 plus the 15 is 35. And then 35 plus 20 is $56. Woo, I'm rich. Okay. So So that's going to be a very important observation, that to get the 56, for example, we don't have to just by from scratch add up all these numbers. All we have to do is say, hey, the 35 here was everything up to and including the 15, and then we just put in the 21. So it's just the sum of these two numbers giving this one. You might want to think about whether that activates something about like, have I seen that kind of thing before? And you might start recognizing these numbers as well. Okay. All right, so let's not worry about EFG quite yet. We've got a new table, a new column, okay? And we've made an observation about efficient ways of doing that. Okay. Um, okay, so here's one of the trickiest parts, I think, in terms of guessing and trying to see patterns. We'd really like to get the closed formula for d sub n. And so I go through some hints here. But the first thing is to just stare at it and really try not to use any hints at all. Use everything we know so far, including the closed formulas for a sub n, b sub n, and c sub n, and see if it seems like there's anything we can say about d sub n. You'll probably need most people need some hints to figure it out. But I'll start that process in the next video.